Today we are going to learn a little bit more about dividing complex fractions. But before we get directly into the computations, let's talk about what a complex fraction really is. Here is the definition of a complex fraction. Please feel free to pause the video and write this down as needed. So a complex fraction is a fraction in which the numerator, denominator, or both are actually themselves fractions. Okay, so let's take a look at an example of a complex fraction. If I have a fraction in my numerator or denominator, such as this one half divided by 3/4. This is called a complex fraction. Okay, here's another complex fraction. 7 divided by 1/5. That's also a complex fraction because it is a fraction in which the numerator, denominator, or both are actually fractions. And another example is 4/5 divided by 9. So here I have a fraction in my denominator. I have a fraction in my numerator in this example, okay? Or I may have a fraction in both. So it's almost like a fraction within a fraction. This bar also means to divide. Please remember that this fraction bar, it means to divide. So when we see that, we can actually replace that division, that fraction bar, with actual division. So let's go ahead and solve a few examples with complex fractions. Let's start with that first one. 1/2 divided by 3/4. 1/2 divided by 3/4. 1/2 divided by 3/4 is the same as 1/2 divided by, because remember this fraction bar means to divide, 3/4. Taking a look back with this division and dividing fractions, we talked about dividing fractions, how we must multiply the first fraction by the multiplicative inverse of the second fraction, which multiplicative inverses gets us 1. And the second fraction, you just flip to do the reciprocal, okay? Here are the multiplicative inverses that we talked about in the past. Remember, if we have a multiplicative inverse, we actually take the first original number, which is 7/9. We multiply it times its reciprocal, which means to flip, and we'll end up with 9/7. Once we cancel out our groups of 1 whole, because 9/9 equals 1, 7/7 equal 1, that's why multiplicative inverses equal 1 whole. So we're going to use this entire rationale, including our dividing fraction rule, to solve this problem. Let's keep the first fraction, 1/2. We're going to multiply by the multiplicative inverse, which is the reciprocal of 3/4, which become 4/3. Because we're dividing two fractions that are positive, okay, they both have the same signs, my final answer should be positive. So I'm going to write that in the corner up here so I don't forget. And I'm going to put a little box so I could come back and put my answer there. So you can either multiply numerator times numerator over denominator times denominator, or we can cancel first. In class, we have been practicing canceling, which is reducing or simplifying before we get to the final answer. Okay, we do that by keeping any fractions that cannot be decomposed But if we can decompose it, such as this 4, I could break that down into 2 times 2. And since my 3 is a prime number, I put the 3 back because the only thing that gives me 3 is 1 times 3. So now I look for fractions that when divided equal 1 whole, such as 2 divided by 2, that equals 1 whole. So I take a look at what's left in my numerator. In my numerator, I have 1 and 2. In my denominator, I have the 3 left. So 1 times 2 is 2. And I have 3 left. And so my final answer is 2/3. And I'm going to go ahead and pop this over here. And so it is positive 2/3. 3/4 divided by 2/3. Remember, this division bar means to divide. That fraction bar means to divide. So I'm going to rewrite it as 3/4 divided by 2/3. I'm going to use the reciprocal I'm going to multiply by the reciprocal of my second fraction, and I'll end up with 3/4 times 2/3. The reciprocal is 3/2. And then I look for ways that I can decompose. And in this case, I'm not able to. 3 times 3 is 9. 4 times 2 is 8. Now this is called a fraction greater than 1 because 8/8 equal 1 whole. So this can be decomposed into 8/8 plus 1/8, right? Because if we remember about fractions with like denominators, okay, 8/8 plus 1/8 equal 9/8. But 8/8 equal 1 whole. So 9/8 is actually equal to 1 and 1/8. I'm going to take a complex fraction that has a whole number and a denominator. 3/12 divided by 9. It's the same thing as 3/12 divided by 9. So when I divide, it will be 3/12 times, what is the reciprocal of 9 as a whole number? You know, all whole numbers can be made into a fraction. How do we make 9 into a fraction? Put 1 as the denominator, right? So now I need to do the reciprocal of 9 over 1, which will give me 1/9. I can see that I can easily take this and reduce it by finding groups of 1 by dividing. 3/12, I'm going to keep the same, times, I can decompose this 1/9 into 3 times 3. I look for ways that I can make groups of 1. 3 divided by 3 is 1. In my numerator, I am left with 1, and in my denominator, I am left with 1 with 12 times 3. Final answer will be 1. 12 times 3 is 36. That is my final answer.